Hi, this session is on adding and subtracting algebraic fractions. So basically algebra that has, fractions that has a bit of algebra in it. But before we do some of these questions, I want to just recap on some other questions that we've covered so far. And I'll start off with some questions from your revision sheet that you just did. Okay, so I'm starting with question 2 from your revision sheet. So with this question, we can see there are two index laws involved. We've got brackets and then we're also dividing. So we'll start off by getting rid of our brackets. Just change my color. So we know that with that index law, with the brackets, you get the power outside the bracket and multiply it with every power inside the bracket. So we end up with x to the power of 6 over x to the power of 10. And now we can see that we can simplify this further. We've got 6 x's on top and 10 on the bottom. So we always cross off our smallest amount, which is the 6 x's, and that becomes a 1. And of course we go 10 take away 6, which is 4. So we're left with 1 over x to the power of 4. Okay, so with this one, it was pretty straightforward. First, get rid of your brackets using that index law we've learned, where you multiply your power with the bracket, with the power inside the bracket. And then the other index law where we said divide the same bases. Okay, our next question involves expanding. And we notice that there's a negative 4g. So we have to be careful with our negatives. So keep that in mind. If it helps, you can circle the negative 4g. Okay, so we have to multiply everything in the bracket with the negative 4g. So we've got minus 4g times 3g and minus 4g times, now this is a negative 5h. Okay, so keep that in mind. Now, you can do this mentally and write down the answer, but if you're not at that stage yet, you can just show some working out. And we'll do one thing at a time. So I'll write minus 4g in brackets times the 3g. Okay, then I'll put a plus, which sort of is saying and. I also have minus 4g times a minus 5h. I'll just squeeze it in. Okay, so it's a minus 5h. So this plus here, you don't see it in the question, but it's simply joining these two together. Okay, and now we've got minus 4 times 3, which is minus 12, and then g times g is g squared. And then plus, we've got minus 4 times a minus 5. So minus 4 times minus 5 is minus 20. And g times h is just gh. We can't add their powers because they're different variables. Now, we're almost done, but we can see we have a positive and a negative sitting together in the middle, and we'll change it to a negative. So we have minus 12g squared, take away 20gh. And that's our final answer. We can't add these two together because they are not like terms. G squared is not the same as GH, so we have to stop there. This question also involves expanding, but you notice we have two sets of brackets. Don't let it confuse you. You just work with one bracket at a time and then simplify what you can. So my first step is I'm going to go 2 times 3i and then 2 times a positive 6. Everything is positive, including this 2, so it's much easier. And also this 5 is a positive 5, so 5 times 6, you can see it's a positive 5, and 5 times 7i. Okay, so let's do the first one. So we've got 2 times 3i. Now, because this is all positive and pretty straightforward, I think we can do this mentally. So 2 times 3i, well, 2 times 3 is 6, and the i just sits there. And then 2 times the 6 is, so it's a positive, and 2 times 6 is 12. Remember, with this one, everything we can see is positive. And that bracket's done. So now we've got the 5 times 6 is positive, so positive 30. And then positive 5 times positive 7i. Well, 5 times 7 is 35, and the I just sits there. Now, we haven't finished. Always check and see, is there anything else we can simplify, anything that we can add together? And I can see that we have a couple of things. We can start with our i's. There's 6i there and a positive 35i there. They are like terms. So 6 plus 35 will give me 41i, and my i's are taken care of. And here I've also got two constants. I've got 12 and the 30. So what is 12 plus 30? And that leaves us with 42. So positive 42. And that is our final answer. There's nothing else we can simplify, and we stop there. Now with the next two questions, these may have confused you at first, but just because the bases are numbers, don't let that confuse you. All we're going to do is the exact same thing as if we had just say x's. So what I mean is, just say question 10 looked like this: x to the power of 5 over x to the power of 7. Now, you should know how to simplify this one here. We have 5 x's on top, so that disappears and becomes a 1. And then 7 take away 5 is 2. Sorry, it's lagging. And we end up with 1 over x to the power of 2. Okay, so this one is one that we've done before. And we're going to do the exact same thing with question 10. But instead of x, we have 8 as our base, but that's fine. We have 5 8s on top and 8 7s on the bottom. So our answer will look similar to this one here, with a 1 on top and x squared on the bottom. And let's try it. So 5 8s on top, that cancels out. The smallest amount becomes a 1. So I have a 1 over. And then 7 take away 5 is just 2. So I have, on the bottom, 8 to the power of 2. And I'm pretty much done, but usually the questions say to simplify, and they also say evaluate. And we know evaluate means to show the value. So what is the value of 8 squared? Can we work it out? Yes, we know 8 times 8 is simply 64. So that is our final answer, especially when we have to evaluate. So with 18, we're doing the exact same thing. Cross off whatever you see on top and bottom that have the same bases. So starting with our 2's, we've got 5 2's on top and 7 on the bottom. My smallest amount is 5, so that can go and it becomes a 1. And 7 take away 5 is 2. And the same with my 5's over here. I've got 5 6's on top and 5 5's on the bottom. 5 is the smallest amount, so that goes, and that becomes a 1. And 6 take away 5 is just, 6 take away 5 is 1. So I've got just 5 on top. So what I'm left with is 1 times 1 on top over 2 to the power of 2 times 1. Okay, and now let's fix this up. Well, 1 times 1 is just 1 over, now 2 squared is 4, and 4 times 1 is 4. So our final answer should have been 1/4. Sorry, I just realized the mistake I made. This should have been a 5 here, because 5 to the power of 1 is 5. Sorry, I forgot that 5 over there. So we should have had 5 over 4. Whoop. And if you turn that into a mixed fraction, 4 into 5 can go once, remainder 1 over 4. Okay, let's try number 11. Okay, so with this question, we can see we're adding or subtracting fractions, and we know we have to have the same denominator when doing this. But our first step can be, I see a positive and a negative sitting together, and that makes a negative, okay? Because I don't have much room, I'll just rub this out and put a negative. Okay, and now all I have to do is make my denominators the same. And I can see my 2, which is the small number, can be turned into a 6 if I multiply it by 3. And what I do to the bottom, I must do to the top. So this fraction here can stay the same, the 5 over 6. So I now have this equals a negative 1 over 6 take away 5 over 6. I now have the same denominators. So my next step is to write them under the same denominator. This is a step you have to include. So I'll squeeze it over here. So they both have the denominator of 6. And I have now, don't forget the minus 1. So minus 1 minus 5 on top. And minus 1 minus 5 on top leaves me with, I'll just squeeze it down here, minus 6 over 6. Okay, and we're almost there. I can see our fraction is going to be a negative fraction because we have one negative, okay? And really this fraction line means division. So one negative, so it's a negative, and 6 divided by 6 is just 1. So our answer is a negative 1 for this question. Okay, I'll just rub it off over here and make some more room. All right, so with our next question, this one here, we have to simplify everything we can on top and bottom. Okay, and we'll start with our 2 and 4. 2 and 4 can be simplified to a half. 2 divided by 2 is 1. 4 divided by 2 is 2. And now let's simplify our algebra. We have 2 a's on top and 1 a on the bottom. So I cross off my smallest amount, which is a on the bottom, or there's a 1 there. And so 1a is gone, and 2 take away 1 is just 1. Now, if you want to, you can start writing it out because it does look a bit messy. So I have a half, and on top I have an a. All right, and now I've got 5 b's on top and 3 b's on the bottom. My smallest amount are 3 b's, that's gone, and 5 take away 3 is just 2, so b squared on top. And now I've got a c and a d. Unfortunately, I can't cancel these out because there's nothing else to cancel it out with. So I have a c on top and a d on the bottom. I can make my 1 invisible. And there we go. That's our final answer. So AB squared C on top and 2D on the bottom. All right, the next one I'll do is question 20. And this one is exactly the same thing as we had before, except there's a time separating two fractions, okay? Now, what some students like to do, they like to multiply it first. And what I mean is you can do this if you really wanted to. You can have AB on top times 6B will give you, let's see, 6AB squared over, and 3 times A is 3A. Sorry, it's lagging. All right, so you can multiply it like this first and then simplify what you can. And I can see we can simplify the A, the 6 and 3. That becomes a 1, and 6 divided by 3 is 2. Cross off my A's. So I'm left with 2B squared over 1, which equals 2B squared. Okay, and that is correct. But a skill that I want you to show me is that you can simplify before you multiply. So if I did this again without multiplying it first, I will cross off my A's, 1 there and 1 there. I will simplify my 3 and 6. That becomes a 1 and that becomes a 2. And now I'll multiply it. So I'll write it out here, sorry. So I have B times 2B over, and that's a 1 over 1. And so 2b times 2b gives me my 2b squared. So you can see how doing it both ways is you get the same answer, but it's important to know how to simplify first because sometimes the questions can be very long and confusing. All right, the next few questions that I'm doing, I've just made them up now, and I want you to have a go and do these first. And you should be able to do most of them because we have covered these in class. All right, with the first one, we can see brackets and a power, and we know with this index law, we multiply every power with the power 2 in this case. So do arrows to remind yourself. B has a power 1, A has a power 2. Oops, it's a bit hard with this. Ooh, hang on a second. Okay, so sorry about my funny arrows, but you can see they're all pointing to the powers. So this 2 is on the outside. I just rubbed it off. That 2 is on the outside, so it's not included. So now make the times visible because the brackets will disappear, and we have another number here. So we've got 2 times. And now we've got multiply your powers. So we're going to have 2 to the power of 4. And then A to the power of 4 and B to the power of 2. All right, this really is not working today. I really apologize. It keeps lagging. Okay, so now that's what you should have had. And now let's evaluate and simplify our numbers. So we've got 2 to the power of 4. So we remember 2 to the power of 4 is 2 times 2 times 2 times 2, and that will give us 16. So that's really 16. And then what is 2 times 16? 2 times 16 is 32. So you should have had 32, then a to the power of 4 and b squared as your final answer. So I'll just rub the working out off. And that's what you should have had. Just the 32, a to the power of 4 and b squared. Okay, so with number 2, we can see we are multiplying. There are 3 fractions. It includes algebra, that's fine. But your first step is, all right, how many negatives do you see? And we can see there is 1 negative. So the whole thing will be a negative. And that's taken care of. Now simplify before you multiply. This one's really easy. I can see an A up here and an A down there, so I'll cancel those off. I can also see a B on top and a B on the bottom, so I'll cancel my B's off. And that's all I can do. So I'm left with, on top, I am left with just a C. And on the bottom, I'm left with a 10. And we're done. There's nothing else for us to do. But remember, it was a negative C over 10. Okay, with 3, this involves the index law that contains the power 0. And we know anything to the power of 0 is simply 1. So we can see here we've got 2 to the power of 0, which the whole thing is just a 1. So we have, you can write 1 and then plus. Now here be very careful. What students do is they think, oh, the whole thing is 1, and they cross it off and write a 1. That's a mistake. Only the x is to the power of 0. 5 has a power of what? Of 1. That is not a 0. So x to the power of 0 is 1, but 5 is still there. And we know that it's really saying 5 times 1, and 5 times 1 is just 5. So we write 5 down on the next line, and we've got 1 plus 5, and 1 plus 5 is simply 6. So you should have had 6 for that one. Okay, with this question here, we'll do one more that involves algebra and what we've done before. So with this one, we can see we have division and we are dealing with fractions. So our first step should be to turn division into times. Okay, it's finally working. All right, and to do that, we have to flip the second fraction. That's your first step. All right, so we'll write it again. A squared b over c times, flip that, we have c over a to the power of 5. And now I'll simplify before I multiply. So I can see I've got a c on top and a c on the bottom, the exact same amount, so I'll cross those off. They just become a 1. I've got 2 a's on top over here, and I've got 5 a's on the bottom. I'll cross off my smallest amount, which is 2, so that's gone and becomes a 1. And 5 take away 2 is just 3. So I end up with a to the power of 3. And my b, unfortunately, has no friends on the bottom, so it's stuck on top. So on top, I have b times 1, which is just b, over 1 times a to the power of 3, which is just a to the power of 3. And we are done. So you should have had b and over a cubed. Okay, so now we are going to move on to the lesson, which is adding and subtracting fractions that involve algebra. Now with this one here, you can see it doesn't involve any algebra just yet, but I will use the same question in a minute. I want you to work this out first, just to make sure you are confident with adding fractions. All right, so we know we need to have the same denominator. So we should have 3 times 5, and then 4 times 5. And there we go. And I know my common denominator will be 15. So I'm going to write that over the same denominator, 15. 4 times 5 is 20. I've got a plus, so plus, and 2 times 3 is 6. And 20 plus 6 now leaves me with 26 over 15. I can see this is an improper fraction. And when you're dealing with numbers, you turn this improper fraction into a mixed fraction. So I can say, how many times does 15 fit into 26? Well, it can fit in there once, and the remainder from 15 to 26 leave me with 11. So 11 over 15. Now for the second question, I've written the same question we had before, but this time I'm going to add something special. I'm going to add some algebra. So I'm going to have on top an x here and also another x next to that too. The same fraction line. All right, so we have the exact same fractions, but now I've added an x there and an x on the other side. So all you have to do when you see algebra and fractions and you're adding or subtracting is do the exact same thing as you would normally, and that is to add this fraction, we have to have the same denominator. So once again, I'm going to go times by 5, times by 5, times by 3, and times by 3. And we multiply it as normally, so it's going to be over 15. And 4x, but this time I've got 4x. But 4x times 5, well, 4 times 5 is 20, and the x just sits there, plus, and on top here, I've got 2 times 3, which is 6, and the x also just sits there. And now this is where it's a little bit different because we've got 20x plus 6x. Can we add these? Yes, we can. They both have an x. They are both like terms, so let's add them. We have 20 plus 6, which is 26, but the x is there, over 15. Now, with algebraic fractions, don't turn an improper fraction into a mixed fraction. We just stop here. Because there's an x up here, you can just stop now. Don't write it as a mixed fraction because we don't do that with algebra and fractions. We stop. We can't simplify 26 and 15, so we've done our final check. There's nothing else to simplify, so we stop here. And that's it. Let's try another one. Okay, I want you to have a go with this one first and see how you go. All right, so once again, all I have to do is make the same denominator. So I can turn my 4 into an 8 by multiplying it by 2. So I'll do that now. All right, so we've got now 2x on top over 4 times 2 is 8. Plus the 3x over 8 stays the same. Now write them over the same denominator. So we've got them over 8. And I now have 2x plus 3x. Now check and see, can we add 2x plus 3x? Yes, we can. That gives us 5x over 8. And we're done. Always double check. Can we simplify the 5 and 8? No, we can't. There's nothing that can go into both of them. So you stop there. Okay, you can have a go at this question first. Now with this one, it looks a little bit different, but remember, we can write 4x over a 1. So we are dealing with fractions, and I have to make the denominators the same. So I can just change my 1 into a 3. I can go times by 3 and times by 3. So the x over 3 stays the same. So I now have, well, 4x times 3 is just 12x, and it's all over 3 plus the x on top, okay? And now I can simplify my 12x and my x. So I now have 12x plus x is simply 13x over 3. Check and see, can we simplify anything else if it comes up? No, we can't. So, and we stop there. Don't turn it into a mixed fraction. Just leave it like as an improper fraction because we have an x sitting there. Okay, with the next one, I want you to have a go first and see how you go. So our first step is we are adding fractions, so we have to have the same denominator. And I can turn my small number 7 into 21 by multiplying it by 3. So I'll go ahead and do that. So times the top and bottom by 3. And I now have 5b times 3 is 15b over 21 plus 2a over 21. Okay, now the next step is you combine them under the same denominator. So I've always told you in class this step's important now, and you can see why. And that is I write 21 once, and now I'm going to have 15b plus the 2a. So 15b plus 2a. And you can see why it's important to include this step, because can we add 15b and the 2a? No, we can't. They are two different like terms, and we have to stop there, okay? Because we can't add the 15b and the 2a, but we combine them under the same denominator. So that's the next step we have to take. So sometimes we can't add the algebra because they're not like terms, and that's where we stop here. All right, you can have a go with this last one, if it works. Okay, so it's 8a over 4, take away 2a over 2. So once again, your first step is to get the same denominators. All right, now I can turn my 2 into a 4 by multiplying it by 2. So I'll do that to the top and bottom. So I'm left with 8a over 4, take away 2a times 2 is 4a over, that's an a, and 2 times 2 is 4. All right, now I'm going to combine them under the same denominator. So they're both over 4, and I have 8a take away 4a. And because they are both a's, they are like terms, I can subtract them. What is 8 take away 4? 8 take away 4 is 4. So I've got 4a over 4. And you can see what your final step should be. We've got a fraction all joined by times, and we can see the 4 and 4 can be cancelled out. So what you should have done was cancelled out this 4 and that 4, simplified those, and we are left with a. Okay, and a over 1, which is just a. So that should have been your final answer. All right, so adding and subtracting fractions involve, at this level, involve the exact same skills as you would normally, but you just add or subtract like terms and simplify where you can. Thank you.